Suppose z is a complex number with positive imaginary parts, with real parts greater than 1, and with the magnitude or absolute value of z equals 2. In the complex plane, the four values 0, z, z squared, and z cubed are the vertices of a quadrilateral with area 15. What is the imaginary part of z? So first let's draw out the complex plane and sketch the points to see what we're dealing with. So we're given that the magnitude of z is 2. This is going to imply that z is going to lie somewhere on this circle of radius 2, centered at the origin. We're also given that z has positive imaginary parts and real parts greater than 1. So this is going to tell us that the number z has to lie somewhere on this arc that I've shown in green. So let's say that z is, for example, this point. Now, we also know that complex numbers, we can express them in polar form. So specifically, I'm going to write z as 2 times e to the I alpha, where alpha is the angle formed with the real axis. This equals 2 cosine alpha plus 2i sine alpha. And one thing to note here is that the imaginary part of z, this is equal to 2 sine alpha. So if I can find sine alpha, then we're good. Now let's look at z squared and z cubed. So whenever we square a complex number, we are squaring the magnitude, and we are also doubling the argument, where the argument is this angle alpha. So z squared is going to be somewhere out here. And note that the magnitude of z was 2, so the magnitude of z squared will be 4. And also the angle that z squared forms with the positive real axis is 2 alpha. This means that the angle in between z and z squared will be alpha. And then z cubed will be done similarly. So z cubed will probably be out here somewhere. Z cubed has magnitude 8. This is also alpha. So according to the problem statement, we're given that the area of this quadrilateral here is 15. Now notice how we split this quadrilateral into two triangles. Each of these two triangles, we know two of the side lengths and the angle in between them, which is alpha. So therefore we can alternatively find the area of this quadrilateral using the formula AB sine C over 2. So 15 is equal to 2 times 4 times sine alpha over 2 plus 4 times 8 times sine alpha over 2. And this will equal 20 sine alpha. So therefore, we can divide both sides by 20, and we'll get that sine alpha is equal to 15 over 20, which is 3/4. Now remember that the imaginary part of z was 2 sine alpha, so now we can substitute sine alpha with 3/4. You see that the imaginary part of z is going to be 3/2, which is choice D.